Hey guys, my name is Tejas and I am studying in Sri Venkateswara College of Engineering. Today let's discuss about a systematic map for improving teaching and learning in undergraduate operating system courses. Introduction. Operating systems is an important area of knowledge included in the curriculum guidelines established by the ACM and IEEE Computer Society for undergraduate programs in computing. Accordingly, an OS course is included in virtually all computing curricula and in some engineering curricula as well. An OS is a software that manages resource sharing and provides programmers with abstraction to control the hardware. Primary OS concepts include concurrency, process management, scheduling, memory management, device management, file systems, and security. These concepts impart an understanding to students about the issues that influence the design of contemporary operating system. The operating system includes of monitor, printer, mouse, keyboard, hardware, and applications. Research methodology. The aim of the present paper was to describe the nature of the research on operating system education. In particular, the overall objective of our study was to identify the range and type of existing research studies addressing the improvement of OS teaching and learning. Therefore, we carried out a systematic mapping studying. This type of review allows to gain an understanding of the purpose and extent of research activity in a given area. The boundaries and purpose of our map were informed by both the review questions and the selection criteria defined below. The question is what approaches have been used to improve operating system teaching and learning. The solution is improving operating system teaching and learning is important because of the technical complexity and practical skills involved. Several approaches has been developed to enhance the effectiveness of operating system education. Hands-on experience and labs, project-based learning, gamification and interactive learning tools, problem-based learning, blended learning. These are the some types of which is used to improve operating system teaching and learning. Data extraction strategy. In the context of an operating system, data extraction strategy refers to methods and techniques used to efficiently retrieve, access or extract data from various sources like fields, databases, memory, devices and other system resources. These strategies ensure that data is gathered in an organized and optimized way, ensuring minimal overhead, avoiding data corruption, and ensuring system security and performance. Key strategies include file system access, memory management, device input-output operations, database extractions, process communication, and synchronization. What approaches have been used to improve operating system teaching and learning based on data extraction strategy? The solution for this question is in recent years, various approaches leveraging data extraction strategies have been used to enhance the teaching and learning of operating systems. These approaches utilize data collection, analysis, and visualization to improve student engagement, understanding, and performance. Some of these methods include learning analytics and data mining, automated assessment and grading tools, adaptive learning systems. Study selection. The selection process aimed to identify papers relevant to the objective of this mapping study. Each article was retrieved by one author and two other authors determined whether it should be included. The inclusion and exclusion criteria are listed below. First one is inclusion criteria. To be included in the review, the papers had to be present an approach to improve teaching or learning in an undergraduate operating system course in an accordance with the main concepts presented in the ACM or IEEE curricula. Concurrency, process management, scheduling, memory management, device management, file systems, and security. Exclusion criteria. Papers were included if the main objective of the discussed operating system course was to learn and non-operating systems such as computer security and software engineering. Papers were also excluded if they were not a full paper. Therefore, we excluded posters, summaries of panel and demo sessions, and similar types of reports. The final results of the searching papers are presented in the table below. Name of the publication, search results are included in the study. The SIG-SCSE proceedings, which the search result is 233 and 39. ITI CSE proceedings, COLI proceedings, IEEE transactions on education, journals of engineering education, International Journal of Engineering Education. These are some final results of searching process. Some approaches used to improve operating system teaching and learning. Using real operating systems such as Linux kernel exploration, students can explore real operating system source code such as the Linux kernel to understand how various operating system components like process management, memory management, and file systems work. And the next one is modifying kernel modules. Instructions can assign tasks where students modify or add kernel modules. For example, writing a device driver or adding a new system call. And the next one is operating systems internals. Courses using a real operating system like Linux or FreeBSD help students navigate the operating system internals directly by running real-world tasks such as process creations, memory allocations, or system calls. Command line interface (CLI). Students learn to work with actual operating system shells, for example Bash or ZSH. Understanding process control, file permissions, user management, and networking. Programming projects. Build an operating system component. A popular project is to have students design and implement key operating system subsystems. For example, building a simple file system, process scheduler, or memory management. Process scheduling algorithms. Implementing various scheduling algorithms, for example, first come, first serve, round robin, etc. In code helps students understand how different scheduling strategies affect performance. For example, some of the scheduling strategies: first come, first serve, priority scheduling, shortest remaining time, shortest job first, round robin scheduling, multi-node queue scheduling. Games and gamification in operating system teaching. Educational games for operating system concepts. Games can be designed to teach scheduling, memory management, and resource allocation by turning these into interactive tasks that students must solve. Simulators with gamification elements. Tools like Little Man Computer simulate a simple processor and memory system, turning learning into a step-by-step problem-solving game where students write instructions for the simulated machine. Simulators with gamification elements. Tools like Little Man Computer simulate a simple processor and memory system, turning learning into a step-by-step problem-solving game where students write instructions for the stimulated machine. Scheduling challenges. Gamifying CPU scheduling algorithms by setting up games where students act as schedulers, trying to maximize efficiency under different algorithm constraints helps students grasp how scheduling impacts OS performance. Deadlock avoidance games. Interactive games where students solve puzzles to avoid deadlocks, for example, preventing resource starvation. Teach synchronization and resource management. Conclusion. In conclusion, the systematic mapping of research on teaching and learning in undergraduate operating systems courses reveals a diverse range of pedagogical strategies tools and methodologies aimed at enhancing student engagement and understanding of complex OX concepts. Future research students focus on addressing these challenges by exploring adaptive learning technologies, improved simulation environments, and interacting cross-disciplinary approaches to make operating system education more relevant to modern industry demands. Additionally, the collaboration between educators and researchers is essential for sharing best practices and continuously evolving the methods of teaching operating systems. Thank you.